In this video, we're going to talk about solving problems that involve plotting points and the coordinate plane. Let's take a look first at a coordinate plane. Here we have one on the right-hand side. Let's focus first on the x-axis right here. You'll notice that that looks just like a number line. It's the horizontal axis, and we refer to that as the x-axis. Positive is to the right, and negative is to the left, just like any number line. Now the y-axis goes up and down, and we can see that the positive numbers, the positive values, are up, and the negative values are down. There's a special point in this coordinate plane that we should talk about. It's right here. That is called the origin. It's where we start all of our plotting. You'll see how that works in a moment. Coordinates are in the form of x, comma, y. So they will be wrapped in a parenthesis like that and have a comma in the middle. And what that's communicating to us is the x value of the coordinate followed by the y value of the coordinate. The x amount is right if it's positive, or it's left if it's negative. And y is up if it's positive, or down if it's negative. Hopefully that makes sense and is logical to you. It's helpful to make sure you keep that straight. So let's make an example here. For example, we have the coordinate 4, comma, -3. You can be thinking about where you would plot that right now. Let's see how this works. We want to treat this as the directions go right 4. And we're going right because it's a positive 4. That tells us to go right. -3 means go down 3. So we want to do these sequentially. We want to go right 4 first and then down 3 next. This is how that looks. We're going to go right 4. And then we're going to go down 3. And there is our coordinates. That is where we would plot 4, comma, -3. Let's take a look at one more before we get into some examples. Another example, -2, comma, 5. Notice it's wrapped in parentheses. That means go left 2, because the 2 is a negative and it's our x part. Go left 2, and then go up 5. Because 5 is positive, we're going to go up. Let's see how that looks on our coordinate plane. We go left 2, we go up 5, and there is the point that we're looking for. That is where we would plot -2, comma, 5. In this video, we are going to review a method of graphing a line that involves making a table of values. We could refer to this as the table method. We are going to graph the line y equals 2x plus 3, and we are going to do it by making a table of x and y values. That looks like this. We have a column for x values, and we have a column for y values. We are going to choose the x values, and then we are going to calculate the resulting y values based on this equation. We're going to pick 2 or 3 numbers for x. 0 and 1 are usually good choices. 2 are absolutely necessary in order to graph a line. Using 3 or generating 3 coordinates helps make sure that you don't make a mistake. So these are the 3 values of x that I chose: 0, 1, and 2. Now we're going to solve for y for each of those x values. That means we're going to substitute 0 for this first one into 2x plus 3 and see what y must be when x is 0. And then we will do that for x equals 1 and for x equals 2. And that will allow us to determine these values. See, 2 times 0 plus 3, y must be 3 when x is 0. When x is 1, 2 times 1 plus 3 is 5. When x is 2, 2 times 2 plus 3 is 7. hopefully you see that pattern. Each time we increase x by 1, y increases by 2. Now, the point of this table is to find coordinates. We then write the resulting coordinates. We use our x value that we chose and the resulting y value. 0, 3 is one coordinate. 1, 5 is our second coordinate. And 2, 7 is our third coordinate. Now that we found our coordinates, we're going to move over to our coordinate plane and plot those resulting coordinates. There is 0, 3. X is 0, y is 3. We plot that point. Next point. X is 1, y is 5. Now, the reason that I suggest a third point is that if we made a mistake on this second point, we would draw the wrong line. But by getting a third point, we can make sure that they're all in a line. And if they're all in a line, then we should be good. Then we know that we didn't make a mistake. That third coordinate is x equals 2, y equals 7. 7 is this point. We're just beyond 6, where these are in increments of 1. So even though it's not labeled, that is y equals 7. And then after that, we just draw the line between all of those points. In this video, we're going to learn how to find slope from a graph. Finding slope from a graph, step 1, we are given a coordinate plane here, and we have a graphed line, and our goal is to find the slope of that line. The first step is to pick any 2 points, but we have to make sure that they're at the intersections in the grid. You can think of the grid as being like a grid of streets, and we want to make sure that the points that we pick are at the intersections of the streets. So let's pick those 2 points. The coordinates would be 2, 2 for this point and 6, 4 for this point. But we don't have to worry about those coordinates. I'm just pointing out where they are. We always want to start out with the point on the left when we're finding slope. This is something that may not be obvious, but I think you'll see why in a moment. So we are going to start out at that left point. Now, our goal in the next step is to start to move to the point to the right. But we're going to go up or down first. So we always want to make that first move either up or down. And if we go up, we're going to think of this as a positive slope. If we have to go down, we're going to think of this as a negative slope. In this first step, we are finding the amount of rise. So graphically, that's how it looks. To get to the point on the right, we have to go up, and we went up 2 units. We're counting the number of units that we went up. So plus 2, that's our rise. Then we go right, always to the right on the second step. That's the reason we started out on the left. When we do that, we are going to find the amount of the run. In this case, the amount of run is 4. We have to go 1, 2, 3, 4 units to the right to get to our second point. Now, that's the first step. We found the values we need to calculate the slope. Now we just need to calculate it. That's what we're going to do in step 2. Here is what we learned in step 1. Our rise was 2, positive 2, and our run was 4. So we're going to set up a fraction with the rise over the run. The slope is equal to the rise over the run. So our rise is 2 over our run of 4. Now, the next step is we either want to divide that if it's going to produce a whole number, or reduce the fraction if possible. We can't divide 2 by 4 and get a whole number, but we can reduce that fraction. And the answer to our question would be 1/2. This line that was graphed has a slope of positive 1/2. In this video, I will review how to find slope when we are given 2 points. The steps to finding the slope from 2 points that are on the line. First of all, we want to label the points. So I'm going to make an example here, 3, 5, and 6, 8. So by labeling them, it helps us substitute into this formula that follows, because we have y2 minus y1 divided by x2 minus x1. This is a formula that's on your GED formula sheet for the slope. We use the letter M to represent slope. So by labeling these points, which we will do some examples of in a moment, it allows us to make sure that we substitute correctly. After we do that, we're going to do the math by subtracting, being very careful with negative numbers, and then finally reduce the fraction. Those are the steps that we will be following. Here's an example of labeling the numbers again. We have 0.1 as 5, 2, 0.2 as 3, 6, and we've labeled it x1, y1, x2, y2, so that we can keep track of it. Now, if we're going to substitute here, we're first looking for y2, that's 6. Then we're looking for y1, we go over here, that's 2. We have now used 6 and 2 from our list. We move down to the bottom of our fraction. X2 is 3, and x1 is 5. So there is the substitution. We can finish this off. 6 minus 2 is 4, and 3 minus 5 is -2. 4 divided by -2 is -2. The slope of the line that goes through those 2 points is -2. In this video, I'm going to talk about recognizing different slope types without actually trying to measure them. Slope is a number that describes a couple of important things about the characteristics of a line: the steepness of the line and the direction, whether it's going up or down from left to right. We'll talk about that a little bit more in a minute. Now on to the idea of estimating slope. Math problems can often be solved with just knowing the type of slope, estimating the type of slope. Estimating the type could be compared to estimating the speed of a car as you're standing along the side of the road. Without any measurement devices, you can easily estimate whether a car is going too fast or too slow, based on your experience in watching cars on a similar road. It's also pretty easy to detect whether a car is speeding up or slowing down without any measurement devices. We don't need to measure the speed in order to know things. We can use our experience. So this idea of estimating slope is similar. We want to practice recognizing the different types of slope, so we don't need to measure all the time. So let's use this chart to first review some of these categories of slope. We can see that there's a bunch of colored lines on here. The first thing I'd like to talk about is that you should really be focused on the right-hand side of this chart. So I'm going to cover up the left side. So we're really focused on the things on the right. Let's go through some of these slope types. This green line, light green line, is a slope of 0. It's a horizontal line. And now I'm going to start to rotate this line up in this direction. As we rotate slightly up, it's a slight positive slope. This line here that I don't have any arrow on would be a slope of 1, positive 1. I'm going to jump past that point, and now we're into the steep positive territory. We go one more step to vertical, and we have an undefined slope. Now let's take a look in the other direction. This red line is rotated from the 0 slightly downward. That's a slight negative slope. Then this line represents a slope of -1, kind of halfway between these points. This blue line would be a steep negative slope. Now, let me be clear that any line that had an arrow in this region here would be a steep negative slope. And then we could also talk about this purple line, but we've already labeled that up here as undefined. Once it rotates back to that vertical point, it would be an undefined slope. I've tried to develop a gauge that can maybe give you another way of thinking about slope. So let me review this positive slope gauge that I created here. You can see that we have a right angle here, and I have a slope of 0 down here, and an undefined slope up here on the vertical line. In the middle, we have a slope of 1. So as we rotate from 0 halfway up, we get a slope of 1. We continue on, we get an undefined slope. Now let me add some of those other kinds of slopes that we've run into in problems. Slopes of 2 or 3 or 4. Those are the exact steepness of those slopes, and you can see where they're located between 1 and undefined. Down here, we have slopes of 1/4 and 1/3 and 1/2, and I could add other slopes to this region, but these are kind of the common ones that we run into. So this covers all of the positive slopes. Now let's take a look at the negative slopes. Here I have 0 again. I have undefined at the bottom. And in this case, we are going to rotate down from 0 toward undefined. There's our slope of -1, halfway in between. Then I can add my steep negative slopes. -2, -3, -4. You can see that these are rotated from 0 quite a ways toward the undefined. That's why they're so steep. There are the gradual negative slopes, -1/4, -1/3, -1/2. Again, I could add lots of other slopes here. This is a whole continuous process of going from 0 up to a large number as we rotate around. In this video, we're going to take a look at how you can use algebra to determine if a coordinate or a point is on a line when you're given the equation for that line. So here's an example. Is the point 1, 3 on the line y equals 2x plus 1? This is the equation for a line, and we're given this point. So let's take a look at the steps. The first thing we want to do is correctly identify the x and y values from the coordinate. So we remember that the first part of the coordinate is x and the second part is y. So that means for 1, 3, x equals 1 and y equals 3. Next, we want to substitute those values of x and y into the equation for the line. That would look like this. We've replaced y with 3, and we replaced x with 1. Now, it frequently works out this way that the way we think about x first and y second, when we substitute, the y is going to come first, and usually the x is going to come second. So just keep that in mind. Now, next, we want to evaluate, simplify this to see if it's true. We get 3 equals 3. We've done this before. We use those x and y values to determine whether the equation is true. If it's true like this, 3 does equal 3, then we know, yes, the point is on the line. If we got something where both sides are not the same, that would indicate that the point is not on the line. Now, this isn't a realistic type of question that you might see on an exam because it's really a true or false kind of question. So let's look at a few examples where we can use this same technique to solve different kinds of problems. This is the first example I want to go through. Which point is on the line? So instead of evaluating one point, we've been given 4 points to work with, and we just have to figure out which one it is. So we basically are going to do the same thing for each point in turn. Now, it's really difficult to guess at what the solution here is. So I would say just work your way through this list, remembering that it is x, y. Now I'm going to go through here and substitute into this equation. Y is 6, x is 1, and we just determine, is that true? So we simplify this right-hand side. 3 times 1 is 3, plus 2 is 5. So in that case, we get 6 equals 5. That's not true. We can rule out answer A. Let's move on to B. Y is 11 is equal to 3 times 3 plus 2. This would simplify to 11 equals 9 plus 2, which is 11 equals 11. That's what we were looking for. There's our answer. We don't have to worry about C and D once we find the correct answer.
In this video, we're going to write the equation for a line when we are given the slope and the y-intercept. Here's our problem. Find the equation of a line with a slope of 2 and a y-intercept of -3. Now, the first thing we want to remember is the form for the equation of a line in slope-intercept form. So in this form, the number that's represented by m is the slope. The number being multiplied by x is the slope, and the number being added or subtracted at the end is the y-intercept. Now, since we're given these two values, we just need to find them. So there's our slope. We will label that as m. And here is our y-intercept. We will label that as b. Now we can replace those in our standard equation format. So y equals, let's fill in our slope of 2. That's going to be multiplied by x. And then we are going to add, and I'm going to put it in parentheses because of the negative, -3. So we're almost done. We just need to simplify that. Y equals 2x. Adding a -3 is the same thing as subtracting 3. And there's the equation for our line. Now, if we chose to, we could graph this. And the first thing I would do in graphing a line when given the y-intercept and the slope is to graph that y-intercept. That is going to be -3 on the y-axis. And then we can plot our slope by moving from this point. Now keep in mind that a slope of 2 is the same thing as the fraction 2 over 1. That's helpful because we know that the top of the fraction is the change in y, and the bottom of the fraction is change in x. So we are going to go up 2 units because it's a positive slope, 1, 2, and over 1, there would be our second point. And we would simply draw a straight line through those 2 points, and we would have a graph of our line.
In this video, we're going to talk about using the point-slope form of a line. There's a formula that will help us put a linear equation in a point-slope form. It's useful when we're given a point on the line and the slope of that line. For example, we're told that there's a line that goes through the point 3, 4, and it has a slope of -2. Let's take a look at the formula. This is a formula that is on the GED formula sheet. Obviously not with these colors, but these colors are going to help us recognize the parts that we need to put into this formula. Namely, we're going to use the coordinates of the point on the line. x1 is going to come from this coordinate, the x value, 3. y1 is going to come from our coordinate, the y value, 4. And slope, which we represent with an m, is going to be -2. Let's watch how this comes together. Our slope is -2. Therefore, m will be substituted with -2. Our point, 3, 4, we want to think of that as x1, y1. And x1 is 3, y1 is 4. There's our formula again. Let's substitute those values in for m, x1, and y1. And it looks like that. Y minus 4 4 is our y1 value. And notice that we're subtracting these, y minus 4. And then on the other side, we have our slope 2 times in parentheses x minus 3. That was our x1 value. Now, the nice thing about problems like this is there is no need to simplify unless there's a double negative.